Hello friends, so here is another question on projectile motion with angular projection. So it is given that a football is kicked at an angle of 30 degree with the vertical. If the horizontal component of its velocity is 19.6 meter per second, find the maximum height and horizontal range. Okay, so let us try to first draw the whole thing and then we'll proceed. So here we have is a football which is kicked at a certain initial velocity, making an angle of, this is the vertical axis, let's say this is the horizontal axis. It makes an angle of how much? 30 degree with the vertical axis. Okay, so all our derivations, formula, it is based on what angle the initial velocity makes with the horizontal axis. So this angle is equal to 60 degree. Okay, the remaining angle. So now it is given that this horizontal component of the initial velocity ux, that is equal to 19.6 meter per second. So ux, we all know, that is equal to u cos theta. So here that implies u cos 60 degree, this is the angle which it makes with the horizontal. So u cos 60 degree, that is equal to 19.6 meter per second. That implies u is equal to 19.6 by cos 60 degree. Cos 60 degree is equal to 1 by 2. So 2 gets to the numerator, gets multiplied. So it is equal to 39.2. Okay, 39, 19 into 2, 38, then 2 into 1.2. Yes, 39.2 meter per second. This is the initial velocity of projection, I mean the velocity with which the football was kicked initially. Now we will we can go with the approach of the component resolution, or you can use the formula. So I have discussed, and I think 3 or 4 questions related to component resolution. So I think that concept is clear. So why unnecessarily extend, make the video lengthy? So we'll go for the direct formula approach. So please watch the beginning videos where I have explained both approaches. First, formula approach, if you remember the formula, that approach, and then if you by chance you are not able to recall the formula, how to resolve every parameter into its x and y components and apply equations of motion to get the desired results. So both approaches I have explained. So they are a bit lengthy videos, so please watch that. So here we'll be using the direct formula. So maximum height, that is equal to u square sine square theta by 2g. So here nothing is mentioned, so we'll take 9.8 meter per second square. So it is equal to 39.2 square into sine 60 degree square by 2, so into 2 into 9.8. So the result is coming around 3 by 2, so it's coming around 58.8 meters. This is the maximum height. So maximum height is equal to 58.8 meters. Okay, then we have is the horizontal range. So horizontal range formula, that is equal to u square sine 2 theta by g. So here it will be equal to 39.2 square into sine 120 degree, and 2 into 60 degree is 120 degree, by 9.8. So it is coming around 135.8 meters. 135.8 meters, yes. This is the horizontal range. Okay, so here we have discussed this question. Here we have used the direct formula approach because I have explained in 3 or 4 questions the component resolution. So I think by now you have got the overall idea how to resolve every parameters, that is the initial velocity, intermediate velocity, acceleration, horizontal and vertical displacements, into the x and y components, and how to apply the equations of motion, the 3 equations of motion in x and y form. Okay, so this is that. So here is another question on projectile motion with angular projection. It is given that if r, capital R, is the horizontal range of a projectile for inclination angle theta, which means with respect to the horizontal axis, and small h is the maximum height of the projectile, then show that the maximum range is given by R max. R max is the maximum range, which is equal to r square by 8h plus 2h, where capital R represents the range for inclination angle theta and small h is the maximum height for same inclination angle theta. So we have to prove it mathematically. So here again 2 important parameters are involved. First the horizontal range and then the maximum height. Okay. So here first let us write down the formula for horizontal range. Horizontal range is equal to u square sine 2 theta by g. Okay, this is horizontal range. Now if you recall, in one of the questions we arrived at an important conclusion that for maximum horizontal range, for range to be maximum, the angle theta should be equal to 45 degree, because when theta is equal to 45 degree, the range for that angle is equal to u square sine 2 into 45 degree, that is 2 theta, 2 into 45 degree, that becomes 90 degree, by g, which is equal to u square by g. Sine 90 degree is equal to 1, and this u square by g is the maximum range achieved by the projectile for a certain projection velocity, and it is only possible when it is projected at an angle of 45 degree with respect to the horizontal. Okay, so for any projection velocity, if it is launched at 45 degree angle, it will cover maximum range. So this is clear. Okay, so this expression, let's keep it in a box, and this R max is equal to u square by g, let's also keep that in the box. Now then is the height, maximum height. Here according to the question, maximum height should be represented by h, so we'll keep it as small h. Maximum height h is equal to, the formula is u square sine square theta by 2g. Okay, this u square sine square theta by 2g. Now r square is equal to u square sine 2 theta by g whole square. Okay, so it is equal to u to the power 4 sine 2 theta square by g square. This is r square. Okay, then 8h, I'm individually calculating these things for representing them in terms of their individual expressions. 8h is equal to 8 u square sine square theta by 2g, and 2h is equal to 2 u square sine square theta by 2g. Now coming back to the main thing. Now r square by 8h plus 2h, that is equal to, first let us write r square. R square here is u to the power 4 sine 2 theta square by g square. R square divided by 8h, so divided by 8h, which is this 8 u square sine square theta by 2g. Okay, let's keep it together. Then plus 2h, 2h is this 2 u square sine square theta by 2g. Okay, so here if we simplify this, u to the power 4 sine 2 theta can be expressed as 2 sine theta into cos theta whole square by g square into, denominator becomes numerator, numerator becomes denominator, 2g by 8 u square sine square theta. Let's keep it in the bracket, plus here 2 will get cancelled, so we'll have u square sine square theta by g. Okay, here also a lot of cancellation will happen, so let's see. So here it is equal to u4, 2 square is equal to 4, here 4 u4 sine square theta cos square theta by g square into 2g by 8 u square sine square theta. Okay, so now the cancellation will happen. 2, 8, that is 4, 4 gets cancelled, sine square theta gets cancelled, u square, this becomes u square here, and this g cancel will, so becomes g. So here we have, this is equal to, okay, this and this remaining, this let's keep it in the bracket, and this is same, u square sine square theta by g. So this becomes u square cos square theta by g, u square cos square theta by g, plus u square sine square theta by g. So from this u square by g we can take common, cos square theta plus sine square theta, this is equal to 1, so it becomes u square by g. Now what is u square by g? Here u square by g is the maximum range, which is equal to R max. So here we have proved mathematically that R square by 8h plus 2h, this much, is equal to u square by g, which is maximum horizontal range. So we have proved this mathematically. Okay, so here again, if you remember the formula, it is necessary that you recall the formula for maximum height and horizontal range, and the concept of theta is equal to 45 degree leads to maximum horizontal range. Okay, so this is both the formulas came into play for horizontal range and maximum height, and remaining is just simple, variable cancellation, rearranging, simplification, that mathematical simplification. But here also you have to, it is important that you don't lose patience. You arrange all the terms carefully and you cancel them carefully. You write them in a proper way so that there is no silly mistakes happening. Okay, so this is the thing.